All right, let's talk about equally likely probabilities. So in probability and statistics, we have a term equally likely, and we're going to talk about each outcome having the same probability. This is one of those where you need to understand the vocabulary and be a little clear. Equally likely doesn't mean that each event is equally likely to happen. It means that each outcome is equally likely to happen. So if you roll a die, then one outcome would be whatever number shows up, but the event would be a combination of outcomes. Okay, so events are more complicated than outcomes in general. So let's do just a quick example based off of that. So we're going to use a fair, balanced, six-sided die. Otherwise, this doesn't work out well. So find the probability of rolling a 1 on the first and on the second. So let's see, this is a little bit complicated. So we need the probability of finding a 1 on the first, so a 1 on the first and a 5 on the second roll. So we have two rolls that are going to happen, and we know that we have 1 out of 6 on the first and 1 out of 6 on the second because they don't affect each other at all. Okay, so that gives us a total of 1 out of 36 using the fundamental counting principle. So it's 1 out of 36 chance of getting that combination. So if we consider the probability of a 4-3 combination, so there's one way to get it on the first and one way to get it on the second. There's 36 possible outcomes, so we're going to get 1 out of 36 again. But that shouldn't be surprising at all. Let's consider now the probability of getting a sum of 6. Well, that's actually kind of tricky to do. So I could make a list of all these. I could get like a 1 and a 5. I could get a 2 and a 4, a 3 and a 3, a 2 and a 4. Oh, I've already done that. A 4 and a 2, and a, let's see, 1, 2, 3, 4. Oh, a 5 and a 1. That gets me a sum of 6. There's 5 ways to do it out of a total of 36 possible outcomes, and there's my answer. And find the probability of getting a sum of 7. You might remember the table that we've built for this already. It turns out that there's 6 ways that I can get a sum of 7, right? 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3. And there's 36 possible outcomes. I could simplify that down to 1 out of 6, or I could keep the 6 out of 36 and understand what's going on. All right, it's probably worth reminding you again that the outcomes of these are the same probability, but each event, which might be constructed of a lot of different rules, each event could be different. Okay, so here we've got a deck of playing cards. There's 52 cards. They're divided into 4 suits, 2 different colors, right? Each suit has 13 cards. These are just facts that we should know about a deck of playing cards. We're going to be using them a lot. And let's see, what's the probability of getting a spade? Well, a spade is a type of suit. So there's 13 cards in the suit, or in the deck. So it's a 1 in 4 chance of drawing a spade if I just take one card. Now, notice that with spades, I could replace that with hearts. I could replace that with clubs. I'm going to get the same result overall. So find the probability of getting a red. Well, there's 2 different colors, so I don't even have to do the 52 thing. It's a 1 out of 2. If I play one card, it's a 1 in 2 chance of getting that outcome. Okay, so now if I take a look at finding the probability of 2 spades in a row with replacement, okay, this is kind of a different question. First of all, this with replacement means I draw the card, then I put the card back. Okay, so I start off and let's see, what's the probability of getting a spade? Well, there's, I guess it's 1 in 4 on the first attempt, and on the second attempt, it's also 1 in 4, which means overall I get, let's see, just multiplying across, I get 1 in 16 chance of getting 2 spades in a row, drawing them straight out. All right, what's the probability of finding on one draw a face card or a red card? So a face card or a red card. Okay, so I got to think about the number of ways that I can get a success out of this. And you know, there's actually a couple of different tricks I could use here. I'm going to go with this one. I'm going to use the rule where I go, or that is the same thing as the probability of the first one plus the probability of the second one, and then subtract out the one where it's both, because I could have a face card that's also a red card. And I feel like this is going to be a little bit faster. Okay, so the probability of drawing a face card, let's see, face cards, I could have a, aces don't count, do they? So Jack, Queen, King, so that's like 3 out of 13. Yeah, 3 out of 13. Plus the probability of, oh, you know what? I'll do it out of the 52 to make life easier. So that's 12, right? 12 out of 52. And then the probability of drawing a red card is, I guess there's 26 out of the 52 cards that are red. But now I have to take away the ones that are both of those. So out of the 52, I'm going to have diamonds and hearts. So three of those for each, so 6 total. Okay. And so when I add all of that together, it's going to be 12 plus 26 minus 6. I get that being 24 out of 52, which you could simplify down to being 6 out of 13. Okay. So by taking these equally likely outcomes, the 1 out of 52 each, and basically combining them creatively, we can solve some pretty complicated looking problems with not a lot of actual calculation. All right, here we've got an example. A woman and a man each have 2 children. I'm going to underline that because that might be important. At least one of the women's children is a boy, and the man's older child is a boy. So find the probability that the woman has 2 boys. Compare that to the probability that the man has 2 boys. Okay, so there's a warning. Consider the events versus the outcomes. Well, if we think about it, I mean, you could either have 2 boys, you could have 1 boy, or you could have 0 boys. I mean, technically, that's kind of the work. Oh, wait, they definitely both have boys, so those are our only 2 outcomes, or those are only 2 events. I think that's right. So yeah, they couldn't have 3 because they each have 2 children. So let's think about this instead by the outcomes. So let's consider the woman. The woman has at least one of them is a boy, which means we could have like 2 boys. We could have the older one is a boy, the younger is a girl, and we could have the older one is a girl and the younger one's a boy. The man, on the other hand, we know that the older one is a boy. So the second one could be a boy, or the second one could be a girl, and that's it. Now, when we think about what happens to the probabilities, we're looking for 2 boys. Those are our only possibilities, which means when we add them up, we're going to get, there's 1 success, but there's 3 possibilities for the woman. Whereas with the man, there's 1 success, but only 2 possibilities in that sample space. The probabilities are actually different because we had to list out what the sample space was overall. So be careful. Sometimes you just try to jump to the conclusion of running the probabilities using the events, but we need to consider the outcomes first. Okay, let's consider the game of roulette now. So roulette is, you basically get a wheel. It's divided into 38 equal slices. You select the winning event, they drop the ball and spin it, and then that's basically how you decide who the winner is. It pays out at different rates. We're not going to worry about that right now. We're just going to worry about winning versus losing. So here, let's find, it's probably worth pointing out here, we've got odds here and odds there. So they are divided up a little bit unusually. And then there's 2 greens. Those green values are actually there so that the casino has a slight edge overall. You can't just 50-50 things. There's 2 ways that you definitely can't win overall. So let's find the probability of A when A is an odd value. So just count the number of outcomes that successfully meet that odd value decision. Okay, so we're going to roll. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Looks like there's 18 ways out of 38 possibilities, and that's going to get us right around, 47.3%. If we consider the number that are red and odd at the same time, so I've got to go to the red, and odd. I've got 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of the 38. So 8 successes out of 38 possibilities. Okay, which is a much smaller value. Let's finish up with one of my favorite kinds of problems. You have two fair balanced 6-sided dice. One's red, one's green. So what's the probability that the value on the green die is greater than the value on the red die? So they're both getting rolled at the same time, or you can take turns. It really doesn't matter for the probability calculations. When we consider this, we should probably remember a couple of quick facts. First of all, there's 36 possible outcomes, right? Because we have 6 of one, 6 of the other, right? 36 possible outcomes. So let's think about how we're going to set this up. I'm going to call my coordinate system the green and the red. Okay, so when I'm writing this out, the green is the first, the red is the second, because otherwise there's not really any particular meaning to it. Okay, so we could start off, and let's go with the green is 6. So the next thing that would win would be a 5. That would be a success. We'd also get a 6 and 4 would be a success, and a 6 and 3. And I don't need to list all of them, but because I think I can count those. I think that's 5. Okay, I think that's 5 ways that I can get success out of it. Let's look at what happens if the green rolls a 5. Well, I can win with a 4. I can win with a 3. So on. I believe 4, 3, 2, 1, because there's no way to roll a 0 with the red. There's 4 of those possibilities. So you can see that by listing these out, I actually have a pretty good chance of calculating them up. So 3, 2, with 1, there's not going to be a success, right? And you'll notice that I haven't quite comprehensively made the list. I've just set the lists up so I could count them reasonably. So overall, that means 5 plus 4 plus 3 plus 2 plus 1 gets me 15 possible ways for the green die to be larger than the red die. So that's 15 out of 36 possible events. All right, I hope that this has helped you out. I look forward to seeing your notes and your homework.